In the last video, we understood how software is developed step by step using SDLC. But let me ask you one thing. Even after following all the SDLC phases properly, why do companies still face delays, failures, and production issues? That's exactly what we will solve today. Welcome to Tech Mastery with Raj. In the previous video, we discussed SDLC, Software Development Lifecycle, in detail. We learned all the phases. So there are 7 phases of the software development lifecycle. First phase is requirement gathering, of course. Second phase is planning. Third phase is design. Fourth one is the development. Fifth one is testing. The next one is delivery or deployment. And the last one is maintenance. So these are the phases we have learned yesterday, and how each phase plays an important role in building a successful application. But there is one important thing we noticed. SDLC tells us what steps to follow, but SDLC doesn't tell us how to make it faster and more efficient. And this is where the real problem starts in the industry. Development team builds the application. Testing team will test it and validates it. Operation team will deploy it and maintain it. But these teams work separately in silos. And what is the result of that? There are delays in deployment. There is a miscommunication, frequent production failures, and sometimes even blame game between teams. So companies needed a better approach, a way to connect all these teams, a way to automate processes, a way to deliver faster and more reliably. And that solution is called DevOps. So today we are starting our DevOps Beginner to Advanced series. And in this video, you will clearly understand what is DevOps, why is DevOps needed, how it works in the real world, what tools are being used in the DevOps, and important interview questions also. By the end of this video, your foundation of DevOps will be very strong. So let's get started. Is one of the most trending skills in IT today. But let me be honest, most people don't really understand it. They just say DevOps means Jenkins, Docker, Kubernetes, Ansible, GitHub, these tools. But that's not DevOps is. Let's break it down. DevOps is equal to development plus operations. But this is just the starting point. DevOps is a culture. DevOps is a mindset and set of practices that helps team deliver software faster, better, and more reliably. Now let's understand each part. Culture. Earlier, developers and operations teams used to work separately. Developers will write the code, then they will hand it over to the testing team. They will test it. Once the testing is done, then they will hand it over to the operations teams to deploy it. That was the SDLC earlier culture. But now in DevOps, they work as one team. Okay, so development plus testing plus operations. They work as a one team. They share the responsibility. And they also share the goal. For example, if production fails, earlier if production fails, operation team used to blame development, and development team used to blame operations. But now whole team solves it together. So that culture has changed in the DevOps. So this is the DevOps culture. Second is the automation. So in traditional system, builds were manual. Testing was also manual, and deployment was also manual. DevOps says automate everything that can be automated. For example, code commit, then automated builds, and then automatic test, and then automatic deployment. So every possible step is automated in the DevOps culture. So this is the second difference. Third is continuous delivery. So instead of releasing software once in 3 months, okay, what DevOps says? DevOps will enable daily or even sometimes multiple releases in a day. So this is continuous delivery. So instead of writing the entire chunk of code, testing it and delivering in one go, once in a 2-3 months, what DevOps says, whatever you have developed today, whatever you have tested today, release it immediately. That is the DevOps culture. Okay. Fourth one is the monitoring. So after deployment, system is continuously monitored in the DevOps. System is continuously monitored in the DevOps. Why? Because real users may face issues, and these tools, the monitoring tools, can track those issues. For example, CPU usage or memory or errors or performance. Any kind of issue will be tracked using the monitoring. So continuous monitoring is also important. And the final simple definition of the DevOps, because earlier we said DevOps is development plus operations, but that is just a starting point. What is the real definition of DevOps is? DevOps is a culture. Okay, let me note it down. DevOps is a culture that combines development and operations to deliver software faster using automation and collaboration. So this is the real definition of DevOps. So remember, DevOps is not just a tool. It's a complete transformation in how teams work. Okay. Now let's see why DevOps is needed. If everything was working fine, DevOps would never exist. So the real question is, what exactly was broken in the traditional software development? Let's understand the real problem companies were facing before DevOps. The first problem was teams silo. In traditional environments, developers and operations teams, they used to work separately. Developers focus on writing a code, and operations will focus on the deployment and maintenance of the systems. But there was a big issue. There was no proper communication between these teams. Let's understand with a simple example. A developer says, my code is working perfectly on my machine. But when it goes to production, operation team says the application is crashing. Now both teams start blaming each other because there is no proper communication. So developer thinks operation team did something wrong. That's why it's not working in the production. Whereas the operation team thinks there is some problem in the code itself. So instead of solving the problem quickly, time is wasted in the confusion and blaming each other. This is what we call the siloed working culture, and it was a major problem in the traditional work culture. Now the second problem is slow releases. Because in traditional system, companies used to release software once in 3 months or sometimes even 6 months. Now think about it. If there is a bug in the production, customer have to wait months to fix the bug. Why was it so slow? Because everything was manual. Testing was manual. Approvals were manual. And even the deployment was manual. So each step required human intervention. One delay in one step can impact the entire release. So software delivery was very slow because it was manual. It was very inefficient and it was not at all competitive. In today's world, where apps updates are available daily, this model simply doesn't work. So this was the second problem in the traditional working style. Now the third problem is the human errors because of the manual work. When deployments are done manually, something can go wrong, right? Someone might forget a file to deliver in the production, which is a necessary file. Or someone might use a wrong configuration in the production. Or someone might deploy a wrong version to the production. Or sometimes even the unnecessary authority will be revoked. Any small mistake can cause a major production failure. For example, a website can go down or application can crash. Users cannot log in. And this directly impact the business revenue and the customer trust. So manual processes were very risky and unreliable. Now, the fourth problem was visibility. So as I mentioned earlier, there was no monitoring as such in the production. So since there is no monitoring, teams did not know when issue happened. And problem is where the issues were detected very late. And that too detected by the users. When user face a issue, he will report it. And then only you will get to know. So there is no visibility. So in many cases, customers are the first to face the issue and report it. Think about that. Your user tells you your system is not working instead of you detecting it first. And this leads to poor user experience, loss of trust, and it impacts your business as well. So these were the problems in the traditional working style. Let's take a real world example. Imagine you're using a banking application. You try to make a payment, but the payment fails. Now what happens? Customer raises a complaint. Customer will raise a complaint. Then support team will create a ticket. After that, development team will start investigation of the code and the operation team will start investigation of the logs. But this process takes hours, sometimes even days. And this whole process, when you are investigating and fixing, your customer is frustrated and business is impacted. This delay happens because there is no automation. There is no proper monitoring of the system and there is a poor collaboration between your teams. Okay. So now this is where DevOps comes into the picture. DevOps solves all these problems by introducing so many things. For example, automation. What happens if you have automated your testing, automated approvals, automated deployment? It reduces the work, and it will also reduce the human errors, because if you are doing it manually, humans can make mistakes. But if you have automated, there is a less chance of failure or making a mistake. So automation helps to improve your work culture. Then continuous testing. Since you have automated continuous testing, it ensures the quality at every stage. Then there is a faster deployment because you have automated. So releases happens frequently. So if there is a issue reported within 1 hour, if you fix it, because you have automated everything, you just need to fix the code, and then your pipelines are ready, so it will be deployed in a production. So user will not be frustrated, and issue will be fixed within minutes, within hour. So it's a faster deployment. Then there is a real-time monitoring in the DevOps. There are some DevOps tools, they will monitor your system continuously. So the moment issue occur, something goes wrong in the production, those monitoring tools will raise alerts to the application teams, and you get to know about the problem, about the issue before customer get to know. So this is the advantage of real-time monitoring. Then there is a better collaboration between development team and operation team, because they are not working separately anymore. They are working together as a one team. Okay. So instead of months, releases can happen daily or even multiple times in a day. So DevOps is not just an improvement, it is a necessity in the modern IT systems. Without DevOps, systems are slow, errors are frequent, customers are unhappy. But with the DevOps, everything becomes faster, reliable, and scalable. So DevOps is very important in today's IT world. Now we will see how DevOps works and what is the DevOps work cycle or life cycle. So now let's understand the heart of DevOps, the DevOps lifecycle. Till now, we understood SDLC, software development lifecycle. Then we understood the what is DevOps. Then we understood why DevOps is needed. But now let's understand how DevOps works. Okay, so how does DevOps actually work in a real companies? So let's break it down step by step. DevOps works as a continuous loop, not a one-time process. Okay, so this is not a one-time process, this is continuous loop. So there are so many stages. First stage is the planning, then code, then build, then test, then release, then deploy, then operate, and then last one is the monitor. These are the stages of the DevOps cycle. So first stage is the planning. Let's understand what comes in the planning stage. So this is the first stage. This is where everything starts. In this phase, business requirements will be gathered, features will be decided, will be planned, tasks will be created and assigned to the team members. So how does the tasks will be assigned? So there can be multiple tools used, but the Jira is the main tool. Most of the companies use Jira for the work assignment or task assignment. So what needs to be built will be decided in this stage. Okay, for example, a company decides we need to build a login feature for our application. Now this requirement is broken down into the tasks, and those tasks will be assigned to the users. So basically planning or defines what needs to be built in this phase. Okay, next phase is the or next stage is the code. This is where the developers start writing the actual code. They will build the features, or if there is any bug which needs to be fixed, those bugs will be fixed, or if there is any change required in the code, those code changes will be made. And once that is done, it though once the code is ready, after the changes or the features implemented, the code will be pushed to the repository. So for that, Git, GitHub, Bitbucket, these tools will be used. Okay. So for example, a developer writes a login functionality and pushes the code to the GitHub. This ensures the version control and the collaboration between the developer. For example, there are 10 developers working on 10 different features. They develop their code and everybody will push their code into the GitHub. So that is the collaboration. Okay, so this is the second phase. Third phase is the build. What happens in the build phase? The code will be compiled. Whatever the dependencies for the code will be downloaded and application will be packaged. For example, raw code will be converted into the runnable application. And this stage ensure code is ready to be tested and deployed. So this build stage is very important. Now, Maven is commonly used tool in this stage for the compilation of the code. Okay, so this ensures the code is ready to be tested and deployed. Now next stage is test. This is the test stage. So there will be automated tests executed in this stage. So there are different kind of testings included. For example, a unit test. So what happens in unit testing is that small parts of the code will be tested, or the integration testing. So testing how components work together, that will be done in this kind of testing. Why is it important? Because we want to catch bugs early in the initial stages, so it will be easy to fix those problems. Instead of finding issues in the production, we want to catch it during the testing. So it will improve the software quality and reliability. So next stage is release stage. So this is where the code is finalized because it is tested. So code is now finalized, ready for the deployment. Think of it as a checkpoint, a version ready to go live. If everything is approved, then we move the code to the deployment. So next stage is deploy. Okay. So now deploy stage where application is deployed to the production environment. This is where users can actually access it, because once it is deployed, it is accessible to the users. So there are many deployment tools. For example, Jenkins will be used for the automation, or a Docker is a containerization tool, and the package will be deployed using the Jenkins pipeline. So there is no manual work required in the deployment. So this because since it is automated, deployment becomes consistent and reliable. So next stage is the operate. Application is live. Users are accessing the application, logging in, making payments, using all features. So operations team ensures systems are running smoothly, servers are stable, and uptime is maintained. So this is the operate stage. And the last stage is monitor. This is the final stage. We continuously track application performance. We monitor errors or logs, CPU usage, response time. So what tools can be used here? For the monitoring purpose, Grafana and Splunk. These are the tools which can be used. There are many other tools, but these are the mostly used tools for the monitoring. What is the use of monitoring? That monitoring tools will track the problems and teams will get alerts immediately. So before customer report the problem, your monitoring tool will report it and you can start working on it and fix the errors in advance. Okay, so this is the monitoring stage. This is the final stage. Okay, so now the most important concept is that This is not a one-time process. This life cycle runs continuously. After monitoring, feedback goes back to planning and the cycle starts again. This continuous process is called CI/CD pipeline. CI stands for continuous integration and CD stands for continuous delivery or deployment. This is what makes a DevOps fast, automated, and efficient. Okay, so this is DevOps lifecycle, and this lifecycle is the backbone of the modern software development. It connects development, testing, deployment, monitoring into one smooth, continuous process. And this is how companies today deliver features faster, reduce errors, and improve user experience. So in this section, we understood the DevOps lifecycle. We will go deeper into the next section and we will understand the benefits of the DevOps cycle. Why are companies investing millions of dollars into DevOps? Because the results are massive. After understanding the DevOps lifecycle, the next question is, what benefits do companies actually get from DevOps? Let's break it down. In the previous section, we saw how DevOps works as a continuous loop. Now imagine that entire lifecycle being automated, fast, error-free. That's where the real benefits comes in. Automated, fast, and error-free. So benefits. One is faster delivery. First and the most important benefit is the faster delivery. Earlier, software releases used to take months. But with DevOps, it's much faster. Daily or sometimes even multiple releases in a day. Why? Because build is automated. Then testing is automated. Deployment is also automated. So instead of waiting for long release cycles, companies deliver features continuously. This helps businesses to respond faster to customer needs or market needs. Then release a new feature quickly and stay ahead of competitors. So this is the first benefit. Second benefit is better quality. Because in DevOps, testing happens continuously. Automated tests run at every stage. During build, before deployment. This means bugs are detected early, fewer issues reach production, because before it reach to production, testing catches it and we fix it. So this is the another benefit. So because of that, what happens? More stability production. Okay, more stable production, more reliable production, and better user experience. So this is the second benefit. Now third benefit is the strong collaboration. Remember, earlier we discussed the problem of team silos. DevOps solves that. Now, developers and operations work together. They share responsibility. Instead of blaming each other, faster issue resolution, better communication, improved team productivity. So this is the third benefit. Fourth benefit is automation. This is the core of DevOps. Okay, because tasks that are manual earlier are now automated. So code integration, automated. Code integration, automated test, automated deployment, right? So the everything is automated. So what happens is it saves time, reduce human errors, and improve consistency. Okay, so instead of manually deploying code, Jenkins can deploy it automatically in minutes. So automation makes the entire process faster and more reliable. So faster bug fixing is the another benefit, is the fifth benefit. So in traditional systems, bugs were detected late. Bugs detected late, sometimes by customers only. Okay, and fixing them took time. In DevOps, monitoring tools detect the issues instantly. Alerts are generated in real time. So teams can identify problems quickly, then fix them immediately, and redeploy updated version fast. So this is another benefit. So because of that, downtime is less and customer impact is also less. So this is another benefit. Now next benefit is scalability. Okay, so modern application need to handle thousands or millions of users, suppose. With DevOps, cloud computing can help scalability. We will see this in detail when we start making videos on the cloud computing. So scale down when not needed. This is again another feature of the cloud. We will understand scalability, scale down, all this in the cloud related series. Okay. So scale up when traffic increase. So when there are thousands of users using your system at a time, it will automatically scale your systems, increase the resources, and when traffic goes down, it will automatically scale down as well. So because of that, it systems performance improves. Okay, and the next benefit is cost. This is very important. Okay, so in the cloud, you pay for the resources what you are using. If you don't use it, you don't pay it. So scalability helps you to scale up and scale down based on the traffic. So if there are millions of users, it will scale up and arrange the resources, and then when traffic goes down, it will scale down and release the resources which are not required. So you will pay for the resources only used during your scale up. Okay, so this is the benefit of DevOps. So let's look at a real world example. Companies like Amazon deploy code thousands of times every single day. Just imagine that thousands of deployments every single day. This is only possible because automation, CI/CD pipelines, DevOps practices. Without DevOps, this level of speed and reliability is impossible. So DevOps is not just about tools or processes. It completely transforms how software is built and delivered. It provides speed, quality, reliability, scalability. And that's why today DevOps is not optional anymore. It is essential for the modern IT systems. Okay. So these are the benefits of the DevOps. Now we will see the important DevOps tools. What are the DevOps tools being used in the market and how important they are? Okay. Now let's clear the biggest confusion about the DevOps. DevOps is not just tools. Many beginners think if I learn Jenkins, Docker, Kubernetes, I know DevOps. But that's not true. DevOps is a culture and process first. And tools are there to support and automate that process. So now let's understand the most important DevOps tools category by category. In the DevOps lifecycle, we discussed earlier, every stage is supported by specific tools. Let's go step by step. First one is the version control tool. Git and GitHub. These are the version control tools. The purpose of the Git and GitHub is to store and manage source code. What does it do? Tracks every code change, allows multiple developers to collaborate, maintains history of the code. For example, a developer writes code and pushes it to the GitHub. Now team members can review, update, and manage code easily. This is the starting point of any DevOps pipeline. Next is CI/CD tools. Most popular tool is the Jenkins. The purpose of the tool is to automate build, test, and deployment. Instead of manually doing everything, Jenkins can pull code from GitHub, build the application, run tests, deploy automatically. For example, as soon as the developer pushes code into the GitHub, Jenkins pipeline starts automatically. This makes software delivery faster, consistent, and reliable. So next tool is configuration management section. In the configuration management, most famous or widely used tool is Ansible. So the purpose of the configuration management tool Ansible is to automate server setup and configuration. Imagine you have 50 servers. Do you configure each server manually? Not practical. With Ansible, you write one playbook and apply configuration to all the servers at a time. For example, if you want to install a software, or if you want to update packages or configure setting on 50 servers, you write one Ansible playbook and run it for all the 50 servers. That Ansible will connect to those 50 servers with the help of SSH connectivity and install that software or update package or configure the setting. So this saves time, effort, and also reduces the human errors. Next tool is for the containerization. So most famous tool is Docker. The purpose of the tool is package application along with its environment. Earlier, it works on my machine, but not on your server. That was the problem teams used to face many times. With the Docker, we solve this problem. It creates a container which runs the same everywhere. So whether it's developer laptop, testing server, or a production server, application behaves exactly same. Next stage and the tool for the next stage is the orchestration. The most famous tool is Kubernetes. The purpose is to manage and scale containers. If you have one container, it's easy. But if you have 100 containers, it is very difficult. So Kubernetes helps to manage those containers, scale automatically, and handle failures. For example, if one container crashes, Kubernetes automatically restarts it. This ensures high availability and reliability. Next tool is for the monitoring purpose. There are many tools, but as I mentioned earlier, Grafana and Splunk, these are the widely used tools for the monitoring purpose. These tools will track system performance and detect issues. These tools monitor logs, errors, CPU usage, application performance, and many more things. For example, if response time increase, it will generate an alert, and that alert will go to the application team. So instead of reacting late, teams can act proactively. Next section is the cloud platform. This is the final category. For example, there are many cloud providers. AWS, which is Amazon Web Service. Azure, it's a Microsoft cloud platform. Google Cloud is GCP, Google Cloud Platform. The purpose is to host applications and infrastructure. Instead of managing physical servers, companies use cloud services. Cloud provides scalability, flexibility, and pay as you use model. And most DevOps tools integrate directly with the cloud platforms. So, if you look at the full DevOps flow, Git manages code, Jenkins automates pipelines, Ansible configures servers, Docker package applications, Kubernetes manage containers, Grafana, Splunk monitor systems, cloud hosts everything. All tools work together to support DevOps lifecycle. So in this video, we understood what is DevOps, why DevOps is needed, DevOps lifecycle, benefits of DevOps, and the tools used in the DevOps. But remember, learning DevOps is not about just theory. In this series, we will learn each tool step by step with practical hands-on examples. And before we go deep into tools and processes, in the next video, we will cover basic DevOps interview questions for the beginner levels. This will help you understand industry expectations, prepare for real world roles. So make sure you don't miss the next video. Follow Tech Mastery with Raj for DevOps made simple. Thank you. Please don't forget to subscribe the channel, like the video, and share it with all your friends who wants to learn DevOps. Thank you.